Hello everyone. In this video we are going to work with Pythagorean theorem and use it to find the missing side of a right triangle. All right, so first let's go ahead and do this summary. The right triangle is a triangle with one right angle. A right angle's measure is 90 degrees. A right triangle has three sides. Two sides form a right angle that form the right angle are known as the legs. The other side is known as the hypotenuse. The hypotenuse is the largest and the longest side. So just remember, and is opposite the right angle. So what we do normally is that you see a right triangle right here. This right here, this square in the corner, that 90-degree angle signifies that you have a right angle. And this is a right triangle. Side A is a leg. Side B is also a leg. And opposite the right angle is the hypotenuse. So the hypotenuse is always the largest side of the triangle. This is the Pythagorean theorem formula. You have a squared plus b squared equals c squared. Just remember, it is important to identify c first. You draw the arrow like I did, opposite the right angle. And once you identify side C, side A and B are interchangeable. So let's get on with some questions. So first question is very, very easy. We're going to use the Pythagorean theorem to find the missing side C. They're not going to be labeled like this, so you have to identify side C. So opposite the right angle, you see how I drew that arrow pointing to side C. So I would just go and say, okay, this is side C. Now I'm just going to write down and use the Pythagorean theorem. I have a squared plus b squared equals c squared. And they give you that on the regions. Side A could be 3 or 4. It doesn't matter. So I'm going to put 3 in. And side B is 4. Side C is the side that you are trying to find. So we are going to leave it just side C. So now we get the calculator going, and we're just going to go ahead and put directly into the calculator 3 squared plus 4 squared. Once you have that into the calculator, you have 25. That equals 25, and it equals c squared. So the opposite inverse operation to something squared is square root. So that's how you would actually use inverse operations to do the opposite operation of squared, which is square root. The square root and the square kind of cancel each other out. So you're just left with c equals, and the square root of 25 is 5. So the way you do that on your calculator is second function and then x squared. All right, and that would be the square root there. If you press the second function and x squared, and you put the 25 in, and you press enter, and you could get 5. So that's how you use Pythagorean theorem to find the missing side. So in two different questions, all right, these are the two questions that you could possibly see. We're going to have the Pythagorean theorem here. As soon as you see a right triangle and a side is missing from that right triangle, you're going to use Pythagorean theorem to find the missing side. The first thing that you do is to create that arrow opposite the right angle. As soon as you draw it, you understand that this side right here is C. When you write down the formula a squared plus b squared equals c squared, you can identify side 12 inches, this side right here as side A, and 5 inches as side B. It does not matter which one is A and which one is B. but it does matter that C remains just C in this case because we're missing that side. So I'm going to substitute into the formula 12 squared plus 5 squared equals C squared. I'm going to grab my calculator and I'm going to put 12 squared, the whole thing in, plus 5 squared, and I'm going to press enter. So now I have 169 equals C squared. The opposite of squared is square root. So you square root both sides. Let me move this over. Once you square root both sides, you have C that's left, and then you do second function square root, 169, and you have 13. So it's 13 inches as side C. So this side would be 13 inches. So when we go over to this question, we realize that this is a little bit different than the other one that we just did. So the first thing though, just make your arrow to side C, and it points to side C. So I'm going to label this side C, I'm going to label this side A, and I'm going to label this B. Now I write down the Pythagorean Theorem formula, and I substitute 16 as the A. B squared will remain B squared because I don't have a number for it. And then now C squared is 20 squared. So this is a little bit different. Now I'm going to press 16 squared just to see what that's equal to. And that is equal to 256. Plus B squared equals 20 squared, which is 400. Now I minus 256. On both sides. This cancels. B squared equals, and we're going to have 400 minus 256, and we get 144. Once that's done, then we square root both sides to get rid of the b squared, and you get b equals, and remember, press second function x squared for square root, and you put 144 in, and you get 12 as your answer. So it's 12 meters. So this is B, side B. So side B is 12 meters. So all of these questions here are a little bit more difficult, but not too bad. So just remember, the first thing that you do is to go ahead and draw that arrow. Then go write the Pythagorean theorem down. A squared plus b squared equals c squared. This one is, this is side A, this is side B, and this is side C. Opposite the right angle is always side C. So I'm going to substitute 13 squared in and 17 squared in for A and B, and c squared will remain c squared. So I'm going to move this over, and I'm going to go 13 squared plus 17 squared. And I'm going to see what that equals, and that equals 458. 458 equals c squared. You square root both sides because you are doing the opposite of what you see. And 458, second function, square root 458. Square root of 458 is 21.4. Rounded to the nearest tenth, the question said, equals 21.4. And it's meters. And that is the question. So, B, the first thing you do is you go ahead and you create an arrow that points to side C, opposite the right angle. Here's side A, and this is side B. Does not matter which one you choose as side A or side B, as long as side C is 10 in this case. So A in my labeling here was 8 squared. B squared remains B squared. You're trying to find this side. And C squared is 10 squared. So 8 squared is 64. B squared remains B squared equals 100. 10 squared is 100. You have to solve for B. So you're going to subtract 64 on both sides. This cancels. And I'm going to move this down a little bit. And B squared is the only thing left on that side. And you get 36. Then you square root both sides because the opposite of squared is square root. And B equals 6 feet. So you found the missing side of 6 feet. So this is 6 feet. All right, so one more, and let's go ahead and just draw that arrow. This is side C. You see how I label it immediately? This is side A, and this is side B. Once I have the labels in, then I could go ahead and put A squared plus B squared equals C squared. A squared remains A squared, because you're looking for that side. B squared is 1, and 4 squared is C. So we have A squared plus 1 equals 16, and you minus 1 on both sides. And you notice that this is not going to be a perfect square. This is A squared equals 15. You square root both sides. Square rooting both sides, you get A equals, and we're going to do get the calculator up. We're going to do second function square root of 15, and we get 3.87, which is 3.9 rounded to the nearest tenth. So this is 3.9 centimeters. And that's how you would figure that out. So you could use the Pythagorean theorem to determine if a triangle is a right triangle. So this is very easy. It's like them giving you all of the sides. So you have all of the answers, and you have to determine if those sides that they gave you are sides of a right triangle. So the first thing that you do, and usually there'll be a box here. This is the right angle right there. And you could go ahead and draw that arrow. Remember, the arrow always points to side C, which is the hypotenuse, which is the greatest side. So if you don't have a triangle, you know that 15 has to be side C. That is the hypotenuse because it's the greatest side. So I'm labeling A and B. And just remember, you could interchange A and B. I'm going to substitute 9 in for A squared. I'm going to substitute 12 in for B squared. I'm going to substitute 15 in for C squared. You notice nothing is blank because we have all the answers. If both sides of the equal sign here, if the left side is equal to the right side, that means it is a right triangle. If it's not equal, then it's not a right triangle. So you're just going to grab your calculator, and you are going to clear this out, and then you're going to do 9 squared plus 12 squared, and we're going to get that is equal to 225. 15 squared on the right side is also equal to 225. Notice that they are equal. Does this represent a right triangle? Yes, it does. And that is it. That's all you have to do. Just substitute the numbers in. Remember, the C has to be in that right spot. Remember, the hypotenuse is the longest side. So if you don't have something that is a triangle staring you in the face, then and you have just 3 sides, you're just basically going to put side C in as 9 and then A and B as anything else. So I'm just going to label it A, B, C, just like you see here. So 6 squared is my A, 8 squared is my B, and 9 squared is my C. So I'm going to take 6 squared plus 8 squared, and that equals 100. Now I know that 9 times 9 is 9 squared, which is 81. This does not equal 100, does not equal 81. It is not a right triangle. So if they're equal on both sides, like you see on the left, that is a right triangle. If they are not equal, as you see on the right, that is not a right triangle. I'll do 2 more here, and because they're so quick. So this is my A, this is my B, and the side that is the greatest side is side C. When I write down A squared plus B squared equals C squared, I'm going to substitute the numbers in, always checking that C is in the right location. So we have now, I am going to just go and put 5 squared plus 6 squared in to my calculator. I'm going to get 61. And that does not equal 100. This is not a right triangle. The next one, we have A, B, and C. We have A squared plus B squared equals C squared. I'm just going to rewrite. I have 36 plus 64 equals 100. And 100 equals 100. You can put it right directly into your calculator. It is a right triangle. Okay, so we could find the distance between 2 points on the coordinate grid, on any coordinate grid, using the Pythagorean theorem. So what they usually do is they give you 2 points, and then you have to connect those 2 points going down and to the left, or to the right and up, to make what it looks like and what is a right triangle. So I'm going to go ahead and do that. So I'm going to go down and to the left, or to the right, whatever. All right, so you could tell right now that I have a right triangle. So basically this right here would be my right angle, and this will be side C, which is what they want the distance of. So the easy part of this is that they'll never give you what C is. They'll just have you find the distance between those 2 points, and those 2 points will always be the hypotenuse. So this makes it a lot easier though, because now once you have a right triangle, you count 1, 2, 3, 4. So that side is 4, and this side is 1, 2, 3. Count the lines, not the boxes. So we have 3 squared plus 4 squared. This is A squared plus B squared equals C squared for Pythagorean theorem. And we have C squared here. So we have 9 plus 16, which is 25, equals C squared. You square root both sides, just like you did all along this lesson. We have C equals 5, and we know that C equals 5. So the distance between those 2 points is 5. And that's it. Further, they're not going to say use the Pythagorean theorem. You have to know if you're finding the lengths between 2 lines, 2 points on a line segment. All you have to do is to connect those points to make it a right triangle. So I'm going to go down and I'm going to go to the right here. So you could see exactly that I have a right triangle, and this is my right angle. There's my C. That's what I have to find the length of. So it's 1, 2, 3. So I'm going to go 1, 2, 3, and then 1, 2, 3. So both sides are 3. We have A squared plus B squared equals C squared. So it's 3 squared plus 3 squared equals c squared. So this is 18 equals c squared. You square root both sides. And again, we're going to round to the nearest tenth. So we have second function square root, 18, enter, 4 points. So c equals 4.24. So 4.2 would be your answer. All right, round to the nearest tenth. Again, we're going to do the same thing here. We see it. So I'm going to go down this time. And I'm going to the right, to the left. That's my left. So this side right here is 2. That's nice. And this side here is 1, 2, 3, 4, 5, 6. So we have side C, it's missing. So we have a squared plus b squared equals c squared. 6 squared plus 2 squared equals c squared. C is the one that's missing. You have 36 plus 4, which is 40, equals c squared. You square root both sides. And then you get c equals square root of 40. Second function, square root of 40. Enter. 6.3 would be your answer, rounded to the nearest tenth. And that's how you would figure out the length between 2 points of a line segment. One of the more difficult questions on any kind of test would be to find the distance between point A and point B without a coordinate grid. They just give you 2 points. So what I would do is find the graph on the rest of the test and then just go ahead and plot it. But right now, in front of you, I'm just going to go ahead and draw what I need. So this is a y-axis and this is the x-axis. So -3, so this could be -3, and -4 would be down here. This would be the point that I'm graphing. 5, 2, so this could be 5, and then 2 could be right here. 5, 2 would be here. So do you see between these 2 points? And if you had graph paper, that would be much easier. But I don't have the graph paper, so I'm just going to connect these 2 points right here. And then on my sketch here, I'm going to go down and I'm going to go to the right. So if you want, you could put -2, -1, this is 0, that's 1, this is 2, this is 3, this is 4, that's 5. So along this stretch, think about it, there's no boxes. We have -3, we go from -3, that's 1, 2, 3, 4, 5, 6, 7. So this is 7. This is -4. So I'm just going to go -3, -2, -1, 0, 1, and then 2. So look, this goes from -4 to 2. So that means 1, 2, 3, 4, 5, 6. 6. So I have my 2 sides, and I'm going to try to get side C, the distance between these 2 points. So I have 7 squared plus 6 squared equals c squared. And I'm going to grab my calculator, do 7 squared plus 6 squared, just to make sure what that is. It is 85. Equals c squared. Square root, this cancels, c equals square root of 85, rounded to the nearest tenth, is 9.2. And that's it. Go ahead, find the graph on the rest of the test, or maybe use some like graph paper. I did a sketch, and I kind of put the numbers in, and I counted that way. Either way would be fine, and that's basically it. All right, that's how you would do that problem. Now I'm just going to do one or two problems with you, and I'll just take number 1. This is the right angle there, and this is side C. So once you identify side C, then you're able to do a squared plus b squared equals c squared. So I'm just going to put a in as 6 squared, put b in as 8 squared. Just remember, 9 squared must be in the place where it needs to be. And remember, you're trying to figure out if these sides form a right triangle. So I'm going to do 6 squared plus 8 squared. And when I enter that, that is 100. 9 squared is 81. We had that before. That's no. Let me do something like number 4. Remember, number 4, A, B, and C already given to you. So you're going to put 2.1 squared plus 7.2 squared equals 7.5 squared. And we're going to see if that equals out 2.1 squared plus 7.2 squared. And that equals 56.25 equals, and then 7.5 squared is 56.25. So this is a yes. So the next problem that I'm just going to do with you is now trying to solve for a missing side. Just like in the lesson, we're going to draw the arrow right to side C. I'm going to label this A, and I'm going to label this B. So I'm going to write down the Pythagorean Theorem, just like this. We have 6.5 squared plus B squared equals 9.9 squared. So I'm going to just do some work here. 6.5 squared. Don't know what that is, but my calculator is going to tell me. That is 42.25. And it's plus B squared, and 9.9 squared, which I don't know. My calculator is going to tell me that that is 98.01. So now I have to solve for B. So solving for B, where you have to get this 42.25 over and away from the side where the B squared is. So I have 98.01 minus 42.25. And it's 55.76. So if you square root both sides, this cancels, B comes down, and we're going to get our answer rounded to the nearest tenth. So we have 55.76, second function, I just pressed the wrong button, second function x squared, and it's 55.76. And this is not going to be, all right, so 7.5 would be your answer, because it's 7.46, and 7.46 rounded to the nearest tenth is 7.5, so B equals 7.5. All right, so I wanted to just do the two problems that are in front of you right now. Exact distance. Just wanted to make sure that you understand what exact distance means between points A and B. So we are going to connect A and B, just like this. And we are going to make a right triangle. And I wanted red, didn't get it. So now I'm going to get red. So just like that and like that. Once you have the right triangle, now you can count your sides, the legs. 1, 2, 3, 4. So we could put 4 here. 1, 2, 3, 4. We could put 4 here. So right now we could just go ahead and put a squared plus b squared equals c squared. A squared is 4 squared plus 4 squared again for b squared. And c squared is the one that you're trying to find. So this is 16 plus 16, which I know is 32, equals c squared. You square root both sides, and c is square root of 32. You leave it there like that. I don't know why I put e. Because this is, oh, I know why. Because this is the exact value. When they say exact value, you don't have to round, right? This is the exact distance. I shouldn't put value, I should put distance, and that's what I'm going to do. This is the exact distance. And I'll prove it to you. Because I know that the square root of 32 is not a perfect square, I'm going to enter. You see this? This number 5.656854249 only stops because the calculator is running out of space. So it's never going to be an exact distance. So when they say exact distance, you leave it as a radical. And a radical, I say, this is the square root. All right. Now it says find your distance between points A and B and round your answer to the nearest tenth. If it says round your answer to the nearest tenth, you know now that you have to round it. And you're not leaving it in the form of a radical or a square root. So this is 1, 2, 3. So I'm going to put 3 here. This is 2. So now we're going to put a squared plus b squared equals c squared. So we have 3 squared. This is a. This is b. This is c plus 2 squared equals c squared. So this is 9 plus 4, that's 13, equals c squared. Now when you square root it, we're not going for the exact distance. We are going for a rounded distance to the nearest tenth. So this is 3.6, so c equals 3.6. And that's the difference between exact, a question that says exact distance, you're leaving the radical, the square root, and a question that says find the distance between points A and B, it's just 3.6. Just remember the rule is consider any right triangle when the short sides have lengths of A and B, and the hypotenuse has a length of C. The hypotenuse is always opposite that right angle. So you're drawing that arrow right from the right angle to side C. Using the Pythagorean Theorem, you either round it or you leave it as an exact value. Example is shown below. And these are 2 examples that when you have side C and B or A, then you would do what you have here on the right hand side. So we have the right hand side. You would just go ahead and find out what side A is, just like that. And knowing that side C and B are given, we would just go ahead and substitute the 12 in as the B and the 13 squared as the C. And then solve it just like you would a 2-step equation. Just remember when you have something that is squared, the opposite of squared is square root. So it's much easier to actually do this one because C is missing. So you're just substituting A and B in as 3 and 4. So we have 3 squared plus 4 squared equals C squared. You add those two together, and remember at the end, when you square root both sides, you get the square root of 25, which is 5. All right, and I hope that video helped, and thank you for watching.